Hello, my dear students. Let us take some more examples on active and passive earth pressure. So, let us take this example. Determine the total passive pressure on the retaining wall shown in figure. Okay. So, here it is, the diagram is given like this. There are two layers and water table is located at a distance of 7 meters from the ground surface. Okay. Here, phi 1 is 28 degree and phi 2 is 32 degrees. So there is a change in the friction. So you have to calculate both Kp1 as well as Kp2. So the pressure distribution diagram, how it comes? Actually, it is here. Suppose if there is a water table here, partially submerged, then this comes like this and exactly it comes like this. But here the phi values are different. So it goes little like this and comes down. Okay. So this is Kp1 gamma into H1 and this is Kp2 gamma into H1. Then this is Kp2 gamma dash H2. This is because of submerged soil and this is due to the water pressure. Okay. So let us find first Kp1, that is 1 plus sine phi divided by 1 minus sine phi. Phi is equal to 28 degree first case. So that is 2.77. Then Kp2, that is 1 plus sine phi divided by 1 minus sine phi. Phi is equal to 32 degree. So we will get 3.25. So once it is calculated, then you can draw what is the pressure distribution diagram. Okay, so this is due to this surface, horizontal surface without submerged soil. So that is Kp1 and this is Kp1. Okay, this is Kp1. Here this is Kp1. Okay, so Kp1 into gamma into H1 and it moves slightly this side because friction is different. So it comes like this. This is Kp2 gamma into H1 and then this portion, this is due to the submerged soil, Kp2 gamma dash H2 and this is gamma W into H2. So let this is Pp1 and this is Pp2 and this is Pp3 and this is Pp4 and this is the total passive earth pressure. Okay, how to calculate this? Let us find first one pressure. I'll find first Pp1. What is that? Kp1 into gamma into H1. What is Kp1? Kp1 is 2.77 into gamma is this 19 into 7. So we will get 368.41 kilonewton per meter square. Next, let us find this. Okay, here this portion, that is Pp2, that is rectangle portion. Kp2 into gamma into H1. Kp2 is 3.25 into gamma. Gamma is 19 into H1, that is 7. Okay, so that is equal to 432.25 kilonewton per meter square. Next, let us find Pp3, this one, due to the submerged soil because water table is located here. So this soil becomes submerged. So this is now Kp2 gamma dash H2. So Kp2 is 3.25. All this below the, at the base is Kp2 only because the friction is here phi 2. Okay. Then Kp2 into gamma dash into H2. So Kp2 is 3.25 into gamma dash is 12 into H2, that is 9. So we will get 351.11 kilonewton per meter square. Then let us find this Pp4, that is due to the water pressure. So that is gamma W into H2. Gamma W is 9.81 into H2, that is 9, this portion 9, that is equal to 88.29 kilonewton per meter square. So this is active earth pressure at the base of the wall. Now let us find the total passive pressure because it is asked to find the total passive pressure. What is the total passive pressure? That is the area of all the pressure distribution diagram. So let us take that first. So this is the diagram. Okay, the same thing I have copied here. So the first one is this PP1. So that is half into KP1 into this is gamma into H1 into H1. This is a triangle portion, this portion PP1. Next PP2, that is this portion. Okay, that is rectangle. So KP2 gamma into H1, KP2 into gamma into H1 into H2, this portion rectangle H2. Then plus here both are triangles, so I'll take K half outside. So half into KP2 into gamma dash into H2 plus gamma W into H2 into H2. Okay, then substitute the values. What is KP1? KP1 half into KP1 gamma H1. This is already we have calculated here. That is 368.41. Substitute that 368.441 or 44 into the H1. Height is 7 meter. Height is 7 meter here. Okay, so that is this plus KP2 gamma H1. That is also calculated here. That is 432.25. So substitute 432.25 into H2 is 9 here. H2 is 9. So plus half into this portion KP2 gamma dash H2, that is 351.11 plus 88.29. So substitute that into H2, that is 9. So we will get 7156.59 kilonewton per meter. This is the total passive earth pressure. Now we have to calculate the point of application where the total pressure, passive pressure exists. Okay, so let us take this point. This is the total passive pressure which is acting at a distance of Z bar, or we can consider it as Y also, no problem. So Z bar. So I'll consider let PP be PE be lying at a distance of Z bar from the base of the wall. So I consider this distance. PP is acting here. So what is that? Total pressure into this Z bar. Total pressure, passive pressure into Z bar, that is equal to the algebraic sum of all the moments to be taken to the toe of the retaining wall. Okay, so what is that? So here PP into Z bar, that is equal to 1/3 of 7 plus 9, because still here we are considering this point, we are considering. So 1/3 of 7 plus this distance, that is 9. Okay, so that's why this is 9 into this is value is here. When you multiply this, you will get 1289.54. Okay, that is this value. Okay, and next is rectangle, this portion, that is here, this value. So that is into half of the rectangle value. Half of this is 9 divided by 2. Okay, so that is 9 divided by 2. So this value, when you multiply, you get this divided by into 9 divided by 2. Okay, then this portion center, I'll consider this as together. So we can add this portion value. Okay, this portion value into 1/3 of 9. Okay, the moment about this point, that is 1/3 of 9. So we will get 5.32 meter. So total passive pressure acting at a distance of 5.32 meter from the base. Okay, like this you have to give the conclusion. I hope all of you understood. Let us take one more example. What is the total active earth pressure per meter length of the wall for soil wall system shown in the figure? Okay, you can see here this figure. This is an inclined surface. In addition to that, there is a surcharge. I have solved one problem related to surcharge, right? And also I have solved one problem related to incline. Now this is the combination of both the cases. One is incline and other case is there is a surcharge. How to draw the pressure distribution diagram? This is due to surcharge, that is KAQ, and this portion, that is due to the inclined surface, that is KA into gamma into H. Understood? Here there is inclined as well as there is surcharge. So we have to draw the pressure distribution diagram first for the surcharge and next for the inclined surface. So surcharge, it is KAQ, and for this inclined surface, it is Ka into gamma into H. And this angle, surcharge angle, is given 10 degree and phi is given 29 degree. So Ka can be calculated by using this formula, that is cos B into cos B minus square root of cos square beta minus cos square phi divided by cos beta plus square root of cos square beta minus square phi. So substitute beta. Beta is equal to, this is beta value. Okay, this is B. That is 10 degree and phi is 29 degree. So we will get 0.364 Ka. After that, you have to calculate earth pressure at the base of the wall. At the base of the wall, that is Ka into Q plus this incline, that is Ka into gamma into H. What is Ka? Ka is 0.364 into Q. Q is 140 plus Ka. K is 0.364 into gamma. Gamma is 18 into H. H is total height, that is 8 meter. So we will get 102.8 kilonewton per meter square. Okay. Next, it is asked to calculate the total active earth pressure per meter length of the wall. So per meter length you have to calculate. So that is nothing but the area of the pressure distribution diagram. Here there are two areas. One is rectangle, one is triangle. So let us calculate that. What is the active earth pressure? That is equal to KAQ into H. KAQ into H. That is Ka is 0.364 into Q is 140 into H is 8 plus this is triangle, half into base into height, half into K gamma H into H. Okay, here there is one more H. This is H square. So we will get half into K is 0.364 into gamma is 80 into H square, that is 8 square. So we will get 612.26 kilonewton per meter square. After that, you have to calculate where that point lies. Okay, maximum active earth pressure, where it is exists, point of application. So what we have to do for that, we have to calculate the total passive earth pressure is equal to the algebraic sum of the moments of all the pressure distribution diagram. So let us take this as PA1. This is PA1, PA2. So I'll consider this is PA. Okay. So this is pressure, total pressure. So PA into Z. This is Z. Okay. Here this is Z bar. PA into Z bar, that is equal to PA1, this one, into PA1 into moment about this point 2, that is, this is the rectangle, so center lies at the center, so half of H, that is half of H by 2, plus PA2, this is a triangle, PA2 into triangle, that is 1/3 of H, that is H by 3. So PAZ bar, PA is the total active earth pressure. So Z bar is equal to, if you write KAQ into H, that is nothing but PA1, KAQ into H by 2 is 8 by 2 plus PA2, that is triangle, half into base into height into H by 3, 8 divided by 3 divided by the total active earth pressure, that is 612.26. So we will get Z bar is equal to 3.56 meter. So this is 3.56. So the total active earth pressure is acting at a distance of 3.56 meter from the base of the wall. Okay, I hope all of you understood. Thank you.